Okay, students, in the previous class, we have finished hybridization theoretically how to do, and in short way, how to find out the hybridization of different molecules. So, a few more molecules I am going to discuss. Other day, I had given examples XCF4, XCOF4. The examples also will do now. XCF4. XCF4. Xenon atomic number and all, if you forget, you do one thing. Xenon belongs to 18th group. Xenon belongs to 18th group. 18th group has 8 valence electrons. You know, noble gases are having 8 electrons other than helium. So you can take directly. So that risk will won't be there. So xenon 8 electrons I am taking. 4, 5, 6, 7, 8. Each fluorine can form one bond with one electron. One bond with one electron. So now count, students, number of sigma bonds and lone pairs. 1, 2, 3, 4. 4 sigma bonds plus 2 lone pairs. Total how much? 6. If the total number of sigma bonds and lone pairs, if it is equal to 6, what is the hybridization? sp3 d2. sp3 d2. XCOF4. XCOF4. Same number of valence electrons you have to take. 4, 5, 6, 7, 8. Here, one oxygen can form 2 bonds with 2 electrons. Observe, students. Since valency of oxygen is 2, so it can form 2 bonds. In that, one must be sigma bond, rest all are rest means second bond is pi bond. If it one particular atom forms multiple bonds, only one will be the sigma bond. Rest all are pi bonds only. Now, Xc 4 fluorines are there, no? One lone pair. So this bond, pi bonds are not involving in hybridization, I told you. So here 1, 2, 3, 4, 5, 6. sp3d2 only. sp3d2. Can you find out hybridization of XCF2, students? Hybridization of xenon in XCF2. Tell me first. Aniketa, correct answer. Remaining students also. Avani, correct answer. Do it first. Easy only, no? Two fluorines are there. Remaining, you just make it pairs, unpaired, lone pairs. Count sigma bonds and pi bonds. Set the correct answer. Very good. So for whoever sent correct answer only they send. See students, 8 valence electrons we have to take. Dhanush correct answer. 5, 6, 7, 8. One fluorine, one more fluorine. Rest all are lone pairs. So here 2 sigma bonds plus 3 lone pairs. Total how much? 5. 5 means which hybridization? sp3d. Now it's a very important example. I3 minus in different ways they are asking. I3 minus hybridization. Here central atom is iodine, bonded atom also iodine only. Before I3 minus, I'll teach NH4 plus. That let it be. In case of ions, how to find out hybridization? You know, nitrogen has 5 valence electrons. Nitrogen has 5 valence electrons. So take 5 valence electrons. But nitrogen is carrying 1 unit of positive charge. When it carries positive charge, students, if it lose electron, plus 1 means it lost 1 electron. So from outermost electrons, you have to remove 1 electron. Understood? If it is carrying positive charge, remove electron based on the number, magnitude of charge, remove required number of electrons. If it carries plus 2 charge, remove 2 electrons. If it carries plus 3 charge, remove 3 electrons. In case of negative charge, it is reversed. So if it carries minus 1 charge, when it carries, it would gain electron. Minus 1 means it gain 1 electron. Minus 2 means it gain 2 electrons. You have to add to the original valence electrons. Okay. In case of ions, follow this one. Now nitrogen has 5 valence electrons. Nitrogen has 5 valence electrons. In that nitrogen is carrying positive charge. It lost 1 electron. So 4 only we have to take. 5 we can't take. Now with 4 electrons, four electron, 4 hydrogens will form bond. So the hybridization is sp3. Hybridization is sp3. Next, SO4 2 minus. Can you find out, students? Sulfur belongs to 16th group. It has 6 valence electrons. 6 valence electrons. Otherwise, if you write electronic configuration also, you will get to know the number of valence electrons. If you remember through group number, it will be helpful. You can save a lot of time. So I am only telling sulfur has 6 valence electrons. My correct answer. Very nice, Tanmay. Aniketa, no. SO4 2 minus. 5 bonds don't count. Yes. Aniketa, correct answer. Avani, correct answer. See, students, Sulfur belongs to 16th group, 6 valence electrons. 2, 3, 4, 5, 6. It is carrying -2 charge, 2 electrons you have to add extra. Now we have 4 oxygens. Each oxygen can form 2 bonds. That one is sigma, another one is pi bond. Pi bond. So you have to consider only sigma bonds. 1, 2, 3, 4. 4 sigma bonds. sp3 hybridization. Easy, students. XeO3 find out. What is the hybridization of xenon in XeO3? All these molecules are very, very important, students. In various competitive examinations, they are asking. XeO3. Xenon has 8 valence electrons. Xenon has 8 valence electrons. 3 oxygens are there. One, two, three, 4, 5, 6, 7, 8. 3 oxygens are there. Counts number of sigma bonds and lone pairs. Now 3 sigma bonds plus 1 lone pair. So many examples I guess. Still many are not giving answer only. sp3. Xe. SF4. Hybridization of SF4. Sulfur in SF4. Sulfur belongs to 16th group. So 6 valence electrons, 4, 5, 6. 4 fluorines are there now. They form bond. 1 lone pair. So now 5 sigma bonds plus 1 lone pair. 6. sp3. Sorry, 4 plus 1. 4 plus 1. 4 plus 1. 4 plus 1 lone pair. 5 sp3 d. sp3 d. sp3d. Now we'll go to I3 minus. I3 minus. Iodine belongs to 17th group. Fluorine, chlorine, bromine, iodine. Fluorine, bromine, iodine. So it belongs to 17th group, halogen family. So it has 7 valence electrons. 3, 4, 5, 6, 7. -1 charge is there, no? You have to keep 1 electron extra. So out of 3 iodines, 1 iodine acts as central atom. Only 2 iodines will form bond with the central atom electrons. Lone pair, lone pair, lone pair. 2 sigma bonds plus 3 lone pairs. 5. sp3d hybridization. Understood, students? How to find out hybridization? Just practice like this, all these examples once again. You know also, if you get doubt anywhere, you can ask. You want me to revise any molecule, repeat any molecule, please let me know. Conditions only, three conditions. One is number of lone valence electrons you have to write. Bonded atoms according to their valency, you have to form the give the bonds. If one atom is forming multiple bonds, in that only one bond will be considered because that is only the sigma bond. Rest all are pi bonds. Next, negative in case of cations, based on the positive charge, remove electrons. In case of anions, based on negative charge, add required number of electrons. Required number of electrons. Okay. So sp3 hybridization, sp3d hybridization. So next one, this is the way to find out hybridization of different molecules. Students, is it clear? No response from your side. If it is clear, tell clear. Otherwise, didn't understand.
Yes, sir, it's clear.
Okay, at least a few students understood. No, remaining they are not asking. Okay, VSEPR theory. VSEPR theory. Here full form is valence shell, electron pair, repulsion theory. Valence shell, electron pair, repulsion theory. Imma, in valency bond theory, some drawbacks were there. Those drawbacks were explained by hybridization. Hybridization main intention is to make all the bonds equally strong, so that molecule will be more stable. So in that way, it explained the stability of molecules. Now there are some failures in hybridization also. It's not failure, somewhat it is a updated one as per theory. So what is this? What are the things explained in VSEPR theory? We'll see first one by one. I'll take one example and I'll explain. NH3, H2O, H2O. Students, what is the hybridization of carbon in CH4? Hybridization of carbon in CH4. Hybridization of carbon in CH4. Already we did this one. Avani, correct. Hybridization of carbon. Tanmay, no. Hybridization of carbon. Sharon, correct answer. sp3, Tripti, correct answer. sp3 hybridization. No lone pairs. NH3, same. sp3 hybridization. One lone pair is there. H2O. If you find hybridization, sp3 only will get. There are two lone pairs. This number is lone pair. Zero lone pairs. Its shape is tetrahedral. Its shape is pyramidal shape. Pyramidal shape. H2O shape is H2O shape. Here one bond, here one bond. V shape or angular shape. Tetrahedral. Tetrahedral. So in hybridization, what they told, all sp3 hybridized molecules are having tetrahedral geometry. Actually, geometry here also correct, but shapes are changing. So that geometry is deviating from tetrahedral to pyramidal, pyramidal to V shape. Hybridization is same, but shapes are different. Shapes of molecules are different. So from this example, what we can say, hybridization alone cannot explain the shapes of molecules. Hybridization alone cannot explain the shapes of molecules. And so many students are having one doubt. Here, if they ask what is the geometry of NH3, I tell it is tetrahedral. What is the geometry of NH3? If they ask, listen carefully, students, don't write now. If they ask what is the hybrid geometry of NH3, I tell tetrahedral. What is the shape of NH3? If they ask, pyramidal shape, I'll tell. What is the difference between shape and geometry? Anyone, can you tell students? What is the difference between shape and geometry? No. Geometry means lone pair of electrons also includes. So geometry includes lone pair. Srivani correct. Geometry includes lone pair, but shape excludes lone pair of electrons. Geometry, if they ask, will consider this entire thing. Okay. Observe carefully, students, what they are asking. They ask geometry, tetrahedral. They ask shape. Okay. From this, what we can say? Shape of the molecule depends on lone pair of electrons. Shape of the molecule depends on number of lone pairs or presence of lone pair distorts the geometry of the molecule. You can write presence of lone pairs distorts the geometry of molecule. Geometry of the molecule. And second point, note down students. Second point, presence of lone pairs distorts the geometry of the molecules. And second point, lone pairs must be arranged in such a way that where the repulsions are minimum. Lone pairs arranged, lone pairs electrons arranged in such a way that where the repulsions are minimum. So while arranging the lone pair of electrons, minimum repulsions we have to check. Presence of lone pairs distorts the geometry of the molecule. Distorts the geometry of the molecules. Next one. So I told lone pairs of lone pairs and bond pairs must be arranged in such a way that where the repulsions occur minimum. So how will you get where in which case repulsions are more, in which case repulsions are less? For that, I am giving one order. Lone pair repulsions are greater than lone pair bond pair. Lone pair bond pair repulsion is greater than bond pair bond pair. BP means bond pair. Why, students? Lone pair size is large. Lone pair size is large. Lone pair is responsible to only one nucleus. But bond pair responsible to two nuclei. Bond means between two atoms only, no? The two nuclei. So size of the nuclei, size of lone pair means lone pair occupies more space than bond pair. So if you keep bulkier groups same side, repulsions will be more. So lone pair uh, arrangement side by side we have to avoid. Lone pair as much as possible. Lone pair we are not supposed to keep side by side. You may get doubt in H2O, you did know, sir. H2O structure is tetrahedral. It is not as if you imagine 3D structure, you will come to know it is not adjacent to each other. Here it is not, lone pairs are not adjacent to each other. This is the order of repulsions. Details. Next one. Lone pairs occupies more lower volume than. Okay. These are the main things. We'll see one by one how the shapes of very very important students. I'm going to give one table how to predict the shapes of molecules from lone pairs and hybridization. Hybridization, lone pair of electrons, shape of the molecule. See here, first I am taking SP hybridization. SP hybridization, no lone pairs. It's not possible in for SP hybridization. We won't get lone pairs. Shape of the molecule is linear. That already we discussed. Linear. Next, sp2 hybridization. sp2 zero lone pairs means no lone pairs. What is the geometry shape of the molecule, students? sp2 hybridized molecules. Other day I have given types of hybridization when I was explaining. Molecules undergo sp2 hybridization. The shape is, geometry is triangular plane. Triangular plane. Planar. sp2, if it contains one lone pair, one molecule is undergoing sp2 hybridization, there is one lone pair. That time what we'll do? Regular structure is for sp2 triangular planar. One of the bond pair occupied by lone pair. Now, which shape you got, students? V shape or angular shape. sp2 hybridization you got, and there is one lone pair. That time shape of the molecule will change to V shape or angular shape. Angular shape. sp2, it is not possible. If it is possible, this lone pairs occupies two bond. So what structure will get? Shape will get linear. sp2 with two lone pairs, linear shape will get. This table will give a lot of information. Please note down. sp3 hybridization, zero lone pairs. No lone pair is there, then shape will be regular. Tetrahedral. CH for example for this. sp3 one lone pair. sp3 one lone pair. See students, from the original structure only I am getting all these things. Now it is pyramidal shape. Pyramidal shape. Example for this, NH3. sp3 hybridization with one lone pair. sp3 with two lone pairs. Here one lone pair, here one lone pair. Anywhere you can. V shape or angular shape. Example is H2. H2. If one more lone pair is there, can you tell students? Could be the shape of the molecule.
Linear.
Linear, Dhanush, correct answer. Avni, correct answer. Linear it is. Because all the three bonds will be occupied by three lone pairs, so it is linear. This molecule is like imaginary, it is very, very unstable. So I can't give example, only linear. Do it, students. Next, sp3d with the zero lone pairs. What is the geometry of molecule, students? sp3d with zero lone pairs. sp3d with zero lone pairs. So what is the regular geometry of sp3 hybridized molecule? Five bonds are there now. Five bonds will get sp3d means. Trigonal bipyramidal. Trigonal planar. So example for this PCl5. Trigonal bipyramidal. Trigonal bipyramidal. Avni, correct answer. Now sp3d one lone pair. And remember students here, lone pair of electrons you are not supposed to keep in equatorial position. In equatorial positions you are not supposed to keep. So sorry students, I told ulta. Lone pair of electrons you are supposed to keep in equatorial position. You are not supposed to keep in axial position. Above bond and below bonds are axial bonds. That time take sp3d regular geometry. One of the bond pair in the equatorial position occupied by lone pair. This is called, it is looking like a tetrahedral but not exactly. So it is called distorted tetrahedral. distorted tetrahedral structure. Example SF4. Distorted tetrahedral. Any molecule is undergoing sp3d hybridization and is having one lone pair. Just to draw the table, I will explain how to apply for the molecule. sp3d hybridization with one lone pair, distorted tetrahedral structure. sp3d, two lone pairs. Two lone pairs will occupy like this. So what do we get, students? Shape of the molecule T shape. You just observe like one English letter T. Example for this BRF3. BRF3. sp3d, two lone pairs, BRF3. So in axial position, don't keep lone pair of electrons. Next one, sp3d. There are three lone pairs. So now all the equatorial positions occupied by electrons. What is the shape of the molecule? Linear. Example for this, XEF2, I3 minus. These are the structure. These are the examples of sp3d with three lone pairs. sp3d with three lone pairs. Next one, sp3d2, sp3d2, linear over no, zero lone pairs. What is a regular geometry, students? Octahedral. Octahedral. How it will distort? sp3d2, there is one lone pair. That lone pair here, lone pairs occupied in axial positions. Here it will occupy. It looks like a square and pyramid. So square pyramidal structure. Square pyramidal. If there are example for this, XCOF4. XCOF4. sp3d2, two lone pairs. Here on one, here on one. This lone pair will be occupied, or bond pair will be occupied lone pair. This will be occupied by bond pair. So shape, if you see, square planar you will get. Example for this, XCF4. Puppet strings. So sp3d2 for two lone pairs. XCF4 is example spare planar. Spare planar example. These are the shapes, molecules with respect to hybridization and lone pairs. Lone pairs. Okay. Now we'll do for some molecules. SO4 2 minus they have given. What is the shape if they ask me? So many compounds are there. Each and every molecule shape you can't remember. By using this technique, you can do it. You can find out. See here, SO4 2 minus. We already did this one, hybridization. sp3, zero lone pairs we got, isn't it? sp3, zero lone pairs. If it is sp3, zero lone pairs, regular tetrahedral only. No distortion in shape. Since 2 units of minus charge is there, no? Like this. tetrahedral structure. XeO3 they asked. XeO3 structure shape they asked. Xenon 1, 2, 3, 4, 5, 6, 7, 8. So each oxygen is forming 2 bonds. So here 3 sigma and 1 lone pair. 4. What is the hybridization? sp3, 1 lone pair, right? So sp3 hybridization geometry is tetrahedral, right? There is 1 lone pair, so it is pyramidal shape. So xenon will be like this. 3 oxygens will form like this. Here there is a lone pair, like this. Pyramidal. Srivani, correct answer. XeO2 F2 देंगे. XeO2 F2. I don't know whether this molecule exists or not. We'll see. Xenon, same. 8 electrons, you have to take valence electrons. 6, 7, 8. 2 oxygens form 4 bonds, 4 electrons, 1 lone pair. Here sigma pi, only 1 bond you have to consider. Sigma and pi. Here both are sigma. 1, 2, 3, 4, 5. What is the hybridization? sp3d. 4 sigma bonds plus 1 lone pair. sp3d hybridization. sp3d hybridization. So sp3d hybridized molecules geometry is trigonal bipyramidal. There is 1 lone pair. So distorted tetrahedral will be Srivani correct answer. Distorted tetrahedral. Xenon will be center. Oxygens and fluorines will be attached. You can find out shape of the molecule if they give molecule. BRF3. BRF3, last molecule. BRF3. Bromine belongs to 17th group, isn't it, students? Halogens. Bromine is halogen. Halogen belongs to 17th group. 17th group elements contain 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Rest all are lone pairs. So here, number of sigma bonds 3, 2 lone pairs. 2 lone pairs. 2 lone pairs. So what is the hybridization? sp3d. 2 lone pairs. sp3d. 2 lone pairs occupy like this. What is the shape, students? T shape. T shape. So Br will be like this, central atom. Fluorines will form bond like this. Here lone pairs. T shape. Okay, ma? Next one. Dipole moment. last but one topic, dipole moment. Important for competitive examination. Dipole moment. Dipole moment means students hope you know what is polar and non-polar bond. Polar bonds and non-polar bonds. I'll give you just a brief explanation. Polar bond means here if you take HCl, here I can tell it is a polar covalent bond. If I take H2, it is not a polar covalent bond. Polar covalent bond is generally heteroatomic molecules have polarity in their bonds. Polarity in their bonds. Because heteroatomic molecule means molecule formed by two types of atoms, two different types of atoms, two different atoms. In that one can be more electronegative, another will be less electronegative. In that case, highly electronegative element try to take electrons, one pair of electrons towards itself. In that moment, electronegative element will get partial negative charge, other atom will get partial positive charge. These are called poles, positive pole, negative pole. It is due to the movement of electrons. Electrons are close to particular atom, means highly electronegative atom. This bond is called polar covalent bond. Polar covalent bond. Why here polarity, students? There is unsymmetrical or unequal distribution of electrons. Covalent bond is formed by equal contribution and mutual sharing of electrons. But slowly, these bond pair of electrons are moving towards one particular atom. One particular atom means which is more electronegative. In that moment, one is getting partial negative charge, one is getting partial positive charge. This type of bonds are called polar covalent bonds. Here, both are having equal strength. They are same atoms, no? How much force of attraction it applies, other hydrogen also applies same force of attraction. So, bond pair of electrons will not move any side. They just presented center of the two atoms. Okay, here polarity won't be there. So this is example for non-polar covalent bond. Non-polar covalent bond, it is a polar covalent bond. Non-polar covalent. So here dipole moment generally happens in polar covalent bonds only. Dipoles, poles has to form dipole moment. So now this dipole moment is represented with the nu. It is the product of magnitude of charge delta. This representation is delta. It represents magnitude of charge. D is distance of separation of charges. Of charges. Distance of separation of charges. So how can we define this one, students? It is the product of magnitude of charge and distance of separation of charges. Write the definition, students. It is the product of magnitude of charge, and distance of separation of charges. Both they'll give, you have to find out dipole moment. More than that, other applications are there. Dipole moment we'll see. Unit of dipole moment is debye. Simply you can represent with the D. Dipole moment, debye is the unit of dipole moment. Unit of dipole moment. Next, applications of dipole moment, students. Few applications we learn. Applications of dipole moment. Applications of dipole moment. First one is to predict the shape of molecules. To predict the shapes of molecules. Shapes of molecules. How to predict? See, students, MX2 type. MX2 type. MX2 type, listen, students, they can arrange in angular shape, or they can also arrange in linear manner. Observe the difference. MX2 type. They can, if I take SO2, this for this example SO2, here CO2. Both are MX2 type only. But yes, in SO2, the SO2 bond shape is like this, molecule shape. Here, CO2 molecule shape is like this. So how to decide? A dipole moment, by using dipole moment only, we can decide. MX2 type dipole moment is equal to 0. Here dipole moment is equal to 0, students. Because groups are arranged symmetrically. Groups are arranged symmetrically. So here dipole moment will be like this. Exactly this dipole, here it is opposite. So resultant dipole moment, electrons will not move any direction. Symmetrical arrangement. Do you think first case is it symmetrical arrangement? No. Both oxygens are in the same plane, same direction. Same direction. So this side dipole moment is more, this side lone pair dipole moment is less. Resultant dipole moment is not equal to 0. So MX2 type molecular formula is MX2 with dipole moment 0 means linear. MX2 with dipole moment is not equal to 0 means angular. In this way, you can predict the geometries of molecule. In examination, they may give MX2 type molecule has a molecule X has molecular formula MX2 and its dipole moment. Experimentally, they found that the dipole moment of the molecule is equal to 0. If they ask, you go through linear shape molecules. In the given option, which is having linear shape, that option you select. If it is not equal to 0, angular shape. Only these two possibilities are there in case of MX2 type. Is it clear, students? MX2 shape molecule, MX2 formula molecules can exist in two shapes. One is angular shape, another one is linear shape. So this is angular in symmetrical arrangement. This is linear symmetrical arrangement. Symmetrical arrangement. Next one, MX3 type. MX3 type. MX3 type can exist in two ways. One is triangular planar, example BCl3, triangular planar. Another one is pyramidal shape, example NH3. Alone, pair and all you don't keep, not required. NH3. In which case dipole moment is equal to 0 out of 1 and 2. In which case dipole moment is equal to 0, students? Observe the structure and tell me. Where or which case symmetrical arrangement is there? Avani, very good. Correct answer. Other students also. Tripti, correct answer. First case dipole moment is equal to 0, students, because this is a symmetrical arrangement. Here it is not equal to 0 because somewhat dipole moment is more towards one direction. Electron movement is represented by using this arrow mark. So resultant dipole moment is not equal to 0. Not equal to 0. Last one, MX4. MX4. MX4 can exist in tetrahedral form. Another one, square planar form. Another case, distorted tetrahedral. Distorted means there is no symmetry. So mu not equal to 0. In this case, both molecules, both shapes, dipole moment is equal to 0. Because symmetrical arrangement, both cases, dipole moment is equal to 0. Tetrahedral and square planar. Square planar. Square planar. You can decide polarity of a solvent also. Polarity of a solvent means dipole, particular solvent dipole moment is not equal to 0 means it is polar solvent. Example, H2O if you take, its shape is like this. Shape is like this. Polarity will be towards more electronegative, oxygen side only. So one side positive charge, one side negative charge. Here dipole moment is not equal to 0. So it is a polar solvent. CCl4 if you take, CCl4, hybridization of C in CCl4 is sp3 hybridization, no lone pair. So it is a symmetrical arrangement. Dipole moment is equal to 0. It is a non-polar solvent. In many chemical reactions, polar and non-polar solvent condition we will use. By using this, you can decide whether the given solvent is polar or non-polar. Polarity of solvent can be decided by using this. And few more applications are there, percentage of ionic character, that and all beyond your capacity. Now don't want to. Now only I'm giving more. Next one, hydrogen bonding. Hydrogen bonding. Have you heard hydrogen bonding, students? Intermolecular attractions, types of attraction, attractive forces. Hydrogen bonding. Next class, this chapter is going to finish, students. So prepare well. Do not that next week only they may conduct exam also. Hydrogen bonding. What is hydrogen bonding? First definition I'll give students. Bond formed between hydrogen and highly electronegative element like fluorine, oxygen, nitrogen is called hydrogen bonding. Write down a definition. Bond formed between hydrogen and highly electronegative elements. What are the highly electronegative elements? Fluorine, oxygen, nitrogen. It's called hydrogen bonding. Hydrogen bonding. Because electronegative difference is more, polarity will be more. So it leads to some attractions. So attractive force is called hydrogen bonding. So hydrogen bonding generally occurs between hydrogen and fluorine or hydrogen and oxygen or hydrogen and nitrogen. Here two types of hydrogen bondings are there. Two types of hydrogen bonding. That just tell you types of hydrogen bonding. Types of hydrogen bonding. One is intermolecular hydrogen bonding. Another one is intramolecular hydrogen bonding. Intermolecular hydrogen bonding means, students, hydrogen bond formed between two molecules of same or different. Two molecules of same or different. Two molecules must be there. Right, Nana? Hydrogen bond formed between two molecules of same or different. So, write example. HF molecule, if you take HF, write like this. So, see, students, here highly electronegative element fluorine, hydrogen. Highly electronegative element fluorine, hydrogen. So here this hydrogen bonding is between two molecules. So it is intermolecular. It is an example for intermolecular hydrogen bonding. Hydrogen bonding. So a few more examples I'll give and properties of hydrogen bonding. And last concept, molecular orbital theory is there, students. Next class I'll finish. So prepare well.